mean, do you think that God came down from heaven and stopped?
So, the issue I've got is I've got my polisher way over there. Phil, let me zoom. There you go, look. Way over there is my polisher. And what I need to do is fit this wire brush. We've got collars, we've got plastic adapters that came with it. I didn't have an end nut because I've only used rat tail conversions. But I bought some M12 by 2, I think they are, whatever size they fit, M14 by 2. I bought some nuts, so we've got nuts, we've got a wire brush, we've got cups, we've got these plastic adapters which I really don't like. I don't think they're going to be up to it, but you never know. Let's see what we can do. Okay, so we've made a sketch. We've got the wheel, we're over at the lathe. We've got a paper aided design pad. And we know that we need to cut a bit of this stock. It's the closest I could find to the size that I need, and that's going to determine a bit for us. But we'll get a chunk cut off and get it in the lathe, eh? So we're off with the obligatory facing up, straight into the centre, then a slight cut back. This aluminium is not super soft and gummy. It machines really nicely, and you can take some really deep cuts. For me, what I consider to be a deep cut when you're going for it. We're in with the centre drill. If you check out my video, it shows where I made Morse taper centre drill holders for both of my lathes, and now I'm starting off with I'll call it a pilot drill, but it's actually 10mm, which is 3/8 near enough, just over 3/8, and we're going to drill that right through this piece of stock because I anticipate that we're going to use most of it to make these adapters for the wire brush. And finally, we're taking it out to size at 16mm, which should give us a nice fit. I didn't see the need to go smaller and then bore it. It's not a precision thing, although it needs to be quite well balanced. Obviously, as balanced as a wire wheel on a big fuck off motor's ever going to be. So now I've just touched on to get a scope for the size. We'll take a very light cut and then measure the material, and we can work out the depth of cut that we need to get to the size that we want to get. That's 37.76, which is not an easy number to work out, but I'll show you a little later on how I find it easy to work out the depth of cut that I need to get to the size that I want. Tom, if you check out Tom's techniques, he really showed me this little sneaky tip with a calculator and using the dial on your cross slide, and it saves you having to do any maths in your head, having to remember any numbers. It really is a game changer. Anyway, back to the plot. So we're machining that shoulder down that's going to sit inside the wire wheel. This is sort of from the right hand side as you look at the machine towards the left. So we're kind of machining it backwards from me. We'll just break those edges. And now we can start to machine the smaller size. Oh look, I'm just checking for size. I'm surprised I broke the edges first. 31.93. If you recall, the drawing's 31.9, so that'll do for me. That's good enough. Now I know that I want to actually have to move the stock in the chuck, which is not something I like to do. But again, it's not a really precision part, and I know that we need enough sticking out to be able to get the rest of the machining done. So I'm going to take the decision and move the stock out of the chuck once I've started and made a few marks on this machine in the next size down, so I'm like machining towards the chuck, but I don't want to machine the actual end of the stock because that's the right size for the wire wheel. So I've swapped to a 45 degree tool. It's actually a 90-degree tool. It cuts 245 chamfers, and I'm taking that down to the next size down. As you can see, it's not fun. We get a lot of swarf and a lot of the chips don't chip, so I'm going to move that out now, give myself enough length, and I think I'll try it a couple of times for concentricity. I don't spin it up with a gauge, it's not that accurate. We'll just eyeball it, see if it shakes, and that's shaking a little bit too much, so we'll just turn the stock slightly as we tweak up the jaws, and with the 3 jaws self-centering, it should get it near enough for this type of application. Measure off with a rule to see that I'm going to get the length that I need, and now we can do a mark with the tool and start doing some serious cutting to get it down to the diameter that we need it to get to. So once again, double check the length, and we'll make a mark and start turning down that part, look, getting it down to size. So we do a few cuts. The problem with doing the really heavy cuts at this stage, obviously, is that if you're not careful, the swarf gets wrapped around the job like you saw earlier. So we're just taking it easy. We're taking that down to the size that we worked out on the sketch earlier. I think we're just going in with a finish cut there, cutting to the right hand side of the work to give us the edge of the thick washer part, if you like, and then we're taking this diameter down to size. On the very end of this there is actually a step down that sits through the housing of the motor and touches on the bearing on the end, so I'm just cutting that step down, and once we get that to size we can finish with the 45 tool and switch over to the parting tool, and then we can part that off, and that's the difficult side of this machining done. So off we go with the parting tool. Cuts nice and easy, this does, no need to add any lube, and we can just work through this. I think I use the power feed just to get it where we want it, and I'll use the swarf brush just to hold it, and away we go. There you go, sorted. That's one off, so that's one done, one to go. Right, I've broke my protocol. I've moved the camera. I want to show you something. I'll just spin you around. So what I've done, I've measured the diameter I've just turned, yeah. I know I've cut back 5mm using this dial gauge on my carriage stop. I've touched off on the face. I've zeroed that out. I've moved the carriage down 5mm, yeah. So I've turned the dial around 5 times. And that's got me this distance, the depth of the step. Now I want to get a diameter. I measured it, it's 36.22, and I know that I want 32 ideally, according to my sketch. Look, where it says 31.9, we've ignored that, and this one's 32 on the fat bit. Goes inside the wire brush. So I'm going to use a calculator. And we're going to go 36.22 minus the size we want, 32, equals, so the part is 4.22mm too big. But because this is a direct measurement, we need to half it to work out our depth of cut. So back to this, divide by 2 equals, we need a cut of 2.11. We can make it even easier. This is a 4mm dial. One revolution is 4mm. It would have been 100 thou when it was an Imperial machine. It's 4mm, so we can take 4mm off that. Minus 4 equals, and we're left with 1.89. Now, if we set this gauge, this dial, to 1.89, which I'm going to struggle to do because I can't hold the outer and turn that and off the camera. But basically, you set that to your figure, 1.89, and when you wind it in until it reaches 0, you've done your depth of cut and you know you're on size. Easy peasy, isn't it? Then you ain't got to remember anything. Little bit of maths, 1.89. Right, we'll set this to 1.89, look. I'm not doing it really, I'm just demonstrating. So 1.89. And now we know that when that's back to 0, when we've wound it all the way into 0, that we've done that depth of cut and that part will measure the right size. Sorted. So that's what I'm going to do. Okay, so part number 2, we're just cleaning off the chamfer that we made with the first part, just to give us a fresh start. And again, we'll take a cut down 5mm down the job and do a measurement, and then using the method I've just shown you, we can work out how much material we need to take off and get bob on to the size. Now we switched over to the 45 and we're doing pretty much a plunge cut, because all we're making now is a really thick washer with that chamfer on the face of it, so we can just plunge into the job, move it towards the chuck, plunge again, move back out to the right, and we can zigzag our way through until we've got enough that we can just part it off. And in with the part until we go. A little bit of oil on the auto feed. The oil don't really help, to be fair, on this, but you know, you can't know that. I think the power feed was a bit savage. Maybe I should have slowed it down a little bit. I'd forgotten that I'd changed the feed rate because I was cutting this alley and wanted to cut it fast. Okay, we've given that a quick deburr. Brought the rags off with a deburring tool, and now we're going to take all bits down to the machine and see if they fit, eh? It's quite exciting, isn't it? So here we go, here it is. Put that on there. I've not even tried this, so this is a live thing. That should fit over there and touch the bearing. That should go on there and be supported at the back. That should go on the front, and then the nut should go on and hold it all nicely. I'll get that nipped up and then we'll see how it runs. That's all nice and tight. We have there we go. Now we should be able to clean things on the wire brush like this, and then we can take them over to the Scotch-Brite. I don't know if you can hear it. And that makes a lovely job. Look, I've got these. They're just showing their age a little bit on the top there, so a quick go on there. No pressure. I don't want to lose all of the patina. I just want to clean the rust off, really. So, quick tickle on there. A light polish on the Scotch-Brite, and the job's a good one. Sorted. So there you go. Thanks for watching. Check out the links, hit subscribe, hit the bell, and please go and follow my friends. Check out the description, yeah? Lots of love, see you soon. Have a great weekend.